This video is to introduce our next unit, which is on statistics, and to give some general vocabulary and some of the concepts here. So let's just start off with a surprising statistical fact. As long as your heart is still beating when you arrive at the hospital, you have a 95% success rate, a 95% chance of surviving a gunshot wound. And that's according to Dr. Vincent J. M. DiMario, a former chief medical examiner in Bexar County, Texas, who wrote a book on gunshot wounds. So 95% chance, that's pretty high. Usually you would think, oh, just bang, bang, you're dead. But let's use that to talk about some vocabulary. Population is the set containing all people or objects whose properties you're getting ready to analyze. So it's pretty much the entire sample space is the population. So in this case, we will be talking about everyone who has ever gotten a gunshot wound, particularly here in America, would be the full population we're talking about. But really, it's unrealistic, right, to track all of those gunshot wounds and to see whether or not each person died. So instead of talking about the entire population, what we need to do is have a sample of that population. A sample is a subset or subgroup of the population. And a sample is random if it's obtained in a way where every element has the same chance of being chosen, right? So if you can choose, so we were picking randomly from the population so that anything in the population could be the one that we choose. And there's lots of different ways that you can have a random sample. Some of the ones we're going to talk about in class are you could do a simple random sampling, which again is like the lottery, okay, where you just put them all in a bowl and you just choose some. You could have a stratified sample. That's where you divide the population into groups by some characteristic, and then you pick some from each group. Or you could do a cluster sample, where you just group the samples in general, and then you just into clusters, and then you would just pick certain clusters and talk about what happens in those clusters. And then you could also do a systematic sampling, where you make a list out of all of them and then pick every like 7th or every 10th element on the list for your sample. Or multi-stage sampling, which is where you combine elements of all of those different kinds. So there are lots of different ways that you could have a random sample. Your sample needs to be a representative sample, and then it needs to have within that sample the same characteristics that you would have of the entire population. So you don't want to pick just a sample that would be like special in some way. You need to make sure that your sample has the same characteristics as the entire population. So after you have your sample, then your sample is made up of each item in your sample is like a data item, and then each of those items will have a certain value. Like if you're, so in our particular example, each data item is a gunshot wound incident, and each data value is talking about the severeness of that injury and whether or not that person survived. So we have all these people who are data items from the population, and then we have the value that's happening for each of those. So once you have your sample, then we are ready to present that data. And there's lots of different ways that you can present the data after you've collected your sample. One of them is with a frequency distribution. A frequency distribution presents the data in two columns. The first column will be each of the data values that were possible, and then the second column will be the frequency. Frequency being the number of times that data value occurred. Okay, so here's an example I have from mathisfun.com, and it has to do with the number of newspapers that a local shop sold over 10 days. And you can see that here are the numbers of newspapers they sold. We could make a a frequency distribution by listing the papers sold and then the frequency of the numbers of times that the papers are sold. Now, it's also possible to group the values, and that would be making a grouped frequency distribution. And then you can see that we've grouped 15 to 19, 20 to 24, and 25 to 29, and found the frequency that each of those occurred at. So this is a grouped frequency table. When we have a grouped frequency table, each of the groups that the table has been split into is called a class. So here I have 3 classes, okay, 3 groups, or when we get in the software, 3 bins, if you will. And each class has to be the same width, has to have the same size. So to find that, we can subtract 19 minus 15, which is the upper limit of the class, minus the lower limit, and we can see that each of these classes have a size of 4. So the class width for each of them is size 4. Also notice that the upper limit of one class does not overlap with the lower limit of the next class. They have to be mutually exclusive, which is separate from each other. I couldn't count from 5 to 10 and then from 10 to 15, because then which bin would 10 go in? Would 10 go in this one or this one? So I would go from 5 to 9 and from 10 to 14. So the numbers don't overlap. Okay, so here we have a histogram of the data. Between 15 and 19, I can see that there are 2, and then 7, and then 1 in this graph. A histogram is just a bar graph where the bars are touching. And the height of the bar represents the frequency. So that's a histogram. A frequency polygon takes a histogram and connects the middle of where each bar would be with dots. And then the ends of the dots have to be drawn, connected back down to the x-axis. Okay. So here is a frequency polygon, which is like a line graph. Okay, a stem and leaf plot separates the data into 2 parts, its stem and its leaf. And one of the benefits of stem-leaf plot is that all of the data is actually represented right on the graph, so you can see what the individual entries are. So let's say I'm going to make a stem and leaf chart of this data. First thing I'm going to do is pull all my stems, and I can see that the tens place here, the highest tens value is an 8, and the lowest tens value is a 4. So I've listed from 4 to 8. So to record 82, then I would come to where 8 is, and we're going to put 2, then 47, 7 would go here, and let's just speed this up. All right, and I added one more down here, 9 for 93. All right, so perhaps you like the stem and leaf chart here because it's pretty visual. But when we're talking about visual representations of data, there are some things that you need to look out for that can be visually misunderstanding. Statistics is great, but a lot of times liars can use statistics to prove points that are not true. And you need to look at how the data is presented so that you can tell what's really going on. So here are some things to look out for.